Rational numbers. Introduction. You begin your study of numbers by counting objects around you. The numbers used for this purpose were called counting numbers or natural numbers. They are 1, 2, 3, 4. By including 0 to natural numbers, we got the whole numbers. That is 0, 1, 2, 3. The negatives of natural numbers were put together with whole numbers to make up integers. Integers are minus 3, 2, 1, 0, 1, 2, 3. We thus extended the number system from natural numbers to whole numbers and from whole numbers to integers. We were also introduced to fractions. These are numbers of the form numerator by denominator, where the numerator is either 0 or a positive integer and a denominator a positive integer. You compare two fractions from their equivalent forms and studied all the four basic operations of addition, subtraction, multiplication and division on them. In this chapter, we shall extend the number system further. We shall introduce the concept of rational numbers along with their addition, subtraction, multiplication and division operations. Need for natural numbers. Earlier, we have seen how integers could be used to denote opposite situations involving numbers. For example, if the distance of 3 km to the right of place was denoted by 3, then the distance of 5 km to the left of the same place could be denoted by minus 5. If a profit of 150 rupees was represented by 150, then the loss of 100 could be written as minus 100. There are many situations similar to the above situations that involve fractional numbers. You can represent a distance of 750 meter above sea level as 3 by 4 kilometer. Can we represent 750 meter below sea level in kilometer? Can we denote the distance of 3 by 4 kilometer below sea level by minus 3 by 4? We can see minus 3 by 4 is neither an integer nor a fractional number. We need to extend our number system to include such numbers. What are rational numbers? The word rational arises from the term ratio. You know that a ratio like 3:2 can also be written as 3 by 2. Here, 3 and 2 are natural numbers. Similarly, the ratio of two integers p and q, that is p ratio q, can be written in a form p by q. This is the form in which rational numbers are expressed. A rational number is defined as a number that can be expressed in the form by p by q, where p and q are integers and q not equivalent 0. Thus, 4 by 5 is a rational number. Here, p equals 4 and q equals 5. Is minus 3 and by 4 also a rational number? Yes, because p equals minus 3 and q equals 4 are integers. You have seen many fractions like 3 by 8, 4 by 8, 1 whole 2 by 3, etc. All fractions are rational numbers. Can you see why? How about the rational numbers like 0.5, 2.3, etc.? Each of such numbers can be written as ordinary fraction and hence are rational numbers. For example, 0.5 equals 5 by 10, 0.333 equals 303 by 1000. In this, we involve feelings. So now let's start numerator and denominator format. Numerator and denominator. In p by q, the integer p is the numerator and integer q is not equivalent o is the denominator. Thus, in minus 3 by 7, the numerator is 3 and the denominator is 7. Mention 5 rational numbers, each of whose numerator is a negative integer and denominator is a positive integer. B. Numerator is a positive integer and denominator is a negative integer. C. Numerator and denominator both are negative integers. D. Numerator and denominator both are positive integers. Are integers also rational numbers? Any integer can be thought of as a rational number. For example, the integer minus 5 is a rational number because we write it as minus 5 by 1. The integer 0 also be written as 0 equals 0 by 2 or 0 by 7, etc. Hence, it is also a rational number. Thus, rational numbers include integers and fractions. Equivalent rational numbers. A rational number can be written with different numerators and denominators. For example, consider the numerator minus 2 and denominator minus 3. Minus 2 by 3 equals to minus 2 into 2 by 3 into 2 equals minus 4 by 6. We see that minus 2 by 3 is the same as minus 4 by 5. Also, minus 2 by 3 equals minus 2 into 5 by minus 3 into 5 equals 10 by minus 15. So, minus 2 by minus 3 is also the same as minus 10 by minus 15. Also, minus 2 by 3 equals minus 2 by 4 equals minus 6 by 10 equals 6 by 10. Such rational numbers can be equal to each other and said to be equivalent to each other. Again, 10 by minus 15 equals minus 10 by 15. Can you see how? Because of them, by multiplying the numerator and denominator of a rational number by the same non-zero integer, we obtain another rational number equivalent to the given rational number. This is exactly like obtaining equivalent fractions. Just as multiplication, the division of the numerator and denominator by the same non-zero integer also gives equivalent rational numbers. For example, 10 by minus 15 equals to 10 divided by minus 5 by 10. Minus 15 divided by minus 5 equals minus 2 by 3. Minus 12 by 24 equals minus 12 divided by 12 equals minus 24 by 12 equals minus 1 by 2. We write minus 2 by 3 as 2 by 3 equals y is the minus 10 by 15 as the world missing files 10 or minus by 15 etc. within it. Start. Positive and negative rational numbers within each. 9.4 is a positive and 9.4 is a negative. Positive and negative natural numbers. Consider a rational number 2 by 3. Both the numerator and denominator number are positive integers. Such a rational number is called a positive rational number. So 3 by 8, 5 by 7, 2 by 9, etc. are positive rational numbers. The number of minus 3 by 5 is a negative integer, whereas the denominator is a positive integer. Such number is called a negative rational numbers. For example, minus 5 by 7, minus 3 by 8, minus 9 by 5, etc. are all negative rational numbers. Is 8 by minus 3 a negative natural number? We know that 8 by minus 3 equals 8 into minus 1 by minus 3 into minus 1 equals to minus 8 by 3, and minus 8 by 3 is a negative rational number, so 8 by minus 3 is a negative rational number. Similarly, 5 by 7, 6 by 5, 2 by 9, etc. are all negative natural numbers. Note that their numerators are positive, positive and their denominators negative. This system is called the rational numbers. The number 0 is neither a positive nor a negative rational number. What about minus 3 by 5? You will see that minus 3 by minus 5 equals minus 3 by minus 5 into minus 1 equals 3 by 5. So minus 3 by 5 is a positive number system, and thus minus 2 by 5, minus 5 by 3, etc. are positive rational number system. Rational numbers on a number line. You know how to represent integers on a number line. Let us draw one such number line. The points to the right of 0 are denoted by plus sign, and are positive integers. The points to the left of 0 are denoted by minus sign and are negative integers. Presentation of fractions on a number line is also known as a U. Let us see how the rational number system can be represented on a number line. Let us represent the number minus 1 by 2 on a number line. As done in the case of positive integers, the positive rational numbers would be marked to the right of 0, and the negative rational number system would be marked on the left of 0. To which side of 0 will mark minus 1 by 2? Being a negative rational number, it would be marked to the left of 0. You note that avoid marking integers on the number line. Succeeding integers are marked at equal intervals. Also from the 0, the pairs 1 and minus 1 is equivalent. So are the pairs of 2 and minus 2, 3 and minus 3. In the same way, the natural number system 1 by 2 and minus 1 by 2 would be at the equal distance from 0. We know how to mark the rational number 1 by 2. It is marked at a point which is half the distance between 0 and 1. So minus 1 by 2 would be marked at a point half the distance between 0 and minus 1. We know how to mark 3 by 2 on the number line. This marks the right of 0 and lies halfway between 1 and 2. Let us now mark minus 3 by 2 on the number line. It lies on the left of 0 at the same distance as 3 by 2 from 0. In decreasing order, we have minus 1 by 2 minus 2 by 2 equals minus 1, minus 3 by 2 minus 4 by 2 equals minus 2. This shows that minus 3 by 2 lies between minus 1 and 2. Thus, minus 3 by 2 lies halfway between minus 1 and minus 2. Mark minus 5 when by minus 2 and minus 7 by minus 2 in a similar way. Similarly, minus 1 by 3 is to the left of 0 at the same distance from 0 as 1 by 3 is to the right. So as 10 above minus 1 by 3 can be represented on a rational number system on the number line. Once we Once we know how to represent minus 1 by 3 on the number line, we can go representing minus 2 by 3, minus 4 by 3, minus 5 by 3 and so on. All other rational numbers with different denominators can be represented in a similar way. Rational numbers in standard form. Observe the rational number system by 3 by 5, minus 5 by 8, minus 2 by 7, minus 7 by 11. The denominators of these rational numbers are positive integers, and 1 is the only common factor between the numerators and denominators. Further, the negative sign occurs only in the numerator. Such rational numbers are said to be in the system form. A rational number system is said to be in the standard form if its denominator is a positive integer and the numerator and denominator have no common factor other than 1. If a rational number is not in the standard form, then it can be reduced to the standard form. Recall that for reducing fractions to the lowest forms, we divided the numerator and the denominator from their fraction by the same non-zero positive integers. We shall use the same method for reducing rational numbers to the standard form. 1. Reduce minus 45 by 30 into the standard form. Solution. We have minus 45 by 30 equals minus 45 by 30 divided by 3 equals minus 15 by 10 equals minus 15 divided by 5 by 10 divided by 5 equals minus 3 by 2. We have to divide twice. First time by 3 and then by 5. This could be also done as minus 45 by 30 equals to minus 45 by 30 divided by 15 equals minus 3 by 2. In this example, note that 15 is the HCF of 45 and 30. Thus, to reduce rational number to its standard form, we divide its numerator and denominator by the HCF, including the negative sign if any. Comparison of rational numbers. We know how to compare two integers or two fractions and tell which is smaller or which is greater among them. Let us now see how we can compare two rational numbers. Earlier, in the case of fractions, 2 Mary complete two negative rational number system minus 1 by 2 and minus 1 by 5 using number line. She knew that the integer which was on the right system of the other integer was the greater integer. For example, 5 is to the right of 2 on the number line and 5 greater than 2. The integer minus 2 is on the right of minus 5 on the number line and minus 2 greater than minus 5. She used this method for rational numbers also. She knew how to mark rational numbers on the number line. She marked minus 1 by 2 and minus 1 by 5 as follows. Has she correctly marked the 2 points? How and why did she convert minus 1 by 2 to minus 5 by 10 and minus 1 by 5 to minus 2 by 10? She found that minus 1 by 5 is to the right of minus 1 by 2. Thus minus 1 by 5 greater minus 1 by 2, or minus 1 by 2 lesser minus 1 by 5. Can you compare minus 3 by 4 and minus 2 by 3, minus 1 by 3 and minus 1 by 5? We know from the study of fractions that minus 1 by 5 greater than minus 1 by 2. And what did Mary get from minus 1 by 2 and minus 1 by 5? Was it not exactly the opposite? You will find that 1 by 2 greater 1 by 5, but minus 1 by 2 lesser minus 1 by 5. Do you observe the same from minus 3 by 4, minus 2 by 3, and minus 1 by 3, minus 1 by 5? Mary remembered that integers which had studied 4 greater than 3, but minus 4 lesser than minus 3, 5 greater than 2, but 5 minus 5 lesser than minus 2, etc. The case of pairs of negative natural numbers is similar. To compare two negative rational number systems, we compare them including the negative signs and then reverse the order. For example, to compare minus 7 by 5 and minus 5 by 3, we first compare 7 by 5 and 5 by 3. We get 7 by 5 lesser 5 by 3 and conclude at minus 7 by 5 lesser minus 5 by 3. Take 5 more such pairs and compare them. Which is greater? Minus 3 by 8 or minus 2 by 7, minus 4 by 3 or minus 3 by 2. Comparison of a negative and a positive rational number system is obvious. A negative natural number system is to the left of 0, whereas a positive rational number is to the right of 0 on the number line. So, a negative rational numbers will be less than a positive rational number thus minus 2 by 7 lesser minus 1 by 2. To compare rational numbers minus 3 by minus 5 and minus 2 by minus 7, reduce them to standard forms and then compare them. 3. 2 minus 4 by 9 and minus 16 by 16 represent the same rational number. Solution. Yes, because 4 by minus 9 equals 4 into minus 4 by 9 into minus 4 equals minus 16 by 36 or minus 16 by 36 equals minus 16 plus minus 4 by minus 35 divided by minus 4 equals minus 4 by 9. What have we discussed? 1. A number that can be expressed in the form PQ, where P and Q are integers and Q is not equal to 0, is called a rational number. The numbers minus 2 by 7, 3 by 8, 3, etc. are rational numbers. 2. There are an unlimited number of rational numbers between two rational numbers. 3. The number 0 is neither positive nor negative. 4. To multiply two rational numbers, we multiply their numerators and denominators separately and write the product as product of numerators by denominators. 5. To divide one rational number by the other non-zero rational number, we multiply the rational number by the reciprocal of the other. Thus, minus 7 by 2 divided by 4 by 3 equals minus 7 by 2 by reciprocal of 4 by 3 equals minus 7 by 2 into 3 by 4 equals minus 21 by 8.